Okay, we're going to talk about arithmetic progressions, otherwise known as APs or series. And in front of you there are a few things that you've probably seen at GCSE. So I reckon you'll have seen all of these at GCSE. Let's put them over this side. And you probably haven't seen this one before. So the reason I've put all of these here on the left is that these are known as sequences. All the ones on the left are sequences, and they're sequences because they have commas. And this one here doesn't have commas, it has pluses, and therefore this is known as a progression or a series. And what we're going to do is, I'm just going to have a look at the sequences first, and I'm going to group them. In fact, I'm going to look at these two last, and I'm going to look at these two first. Now, the first two are called an arithmetic progression. And the reason, sorry, not progression, an arithmetic sequence. The reason they're called an arithmetic sequence is, can you see that this one here goes up by 3 each time, and this one here goes down by 2 each time. So what both of them have is they have this thing called a common difference, and the common difference is an adding or a subtracting difference, and it's the same each time. So they are known as arithmetic sequences. Now notice that one of them stops, therefore it's called finite, and one of them doesn't stop, therefore it's called infinite. Now if we look at the two down the bottom, what's happening with these two? These are not arithmetic. This one here, can you see that this one goes up 1 plus 2 plus 1 plus 2? So there's no common difference happening. This difference changes each time. Therefore, that is not anything arithmetic. And this one isn't going up by anything. It's not going up by an add or a minus. It's actually timesing by 10. And we'll look at those in C2. But that is also not an arithmetic. Now, over here, this is probably, so you've done those at GCSE. What we do with you guys at A-level is we start looking at what happens when instead of commas we put pluses in, and this is now called a progression, and this of course goes up by 3 each time, so it's known as an arithmetic progression. Okay, so the first thing we're going to do is we're going to find the nth term of an arithmetic progression known as an AP. Now I suspect most of you have done this, haven't you, at GCSE, because you'll say to me, okay, the nth term, let's write it up here. So the nth term is, okay, what's the common difference? The common difference is 3. They go up by 3 each time, so it's going to be 3n. And I suspect you a lot are used to writing something like this. Okay, so this is when n is 1, that's the first one. And this is when n is 2, and this is when n is 3, and this is when n is 4. Okay, so if we took one, let's say we took the 11, when n is 4, we're going to get 3 lots of 4, which is 12. And how do we get 11 minus 1? So most of you from GCSE can already find the nth term. What we're going to do at A-level is we're going to have a different formula. Well, it's the same. It will lead to the same thing. It will still be 3n minus 1, but it's going to be generated in a slightly different way. So in order to do that, I'm going to start to need to show you a little bit of notation. So the first thing that I'm going to say is, at A-level, we don't refer to the first term as n equals 1. What we do is we refer to it as u1. And therefore n2, we refer to that, that's the second term, as u2. And n is 3, we refer to that as u3. And this one here is u to the 4. Okay, now the other thing, just to make life complicated, is that the first term is also referred to as A. So U1 is exactly the same as me writing A. Now, let's start off and see if we can generate this formula for the nth term. So actually what I would refer to the nth term as is U to the n. So I'm interested in what this number here, right at the end, any term of my series, could in fact be. So if you have a look at this, the very first term, the 2, is referred to as A. So what is my formula for my nth term? Well, the first one is A. The second one is referred to as A plus the difference, because the difference we said was 3, wasn't it? How do I get the second term? I do A plus D. So we're plussing because there's a plus in between them. The third term is referred to as a plus, how do I get it? Well, I started with 2, I added the difference, and I added the difference again. So it's a plus 2d. So if I'm interested in this very last one, this nth term, if we have a look at the pattern, the first term is a, the second term here is when we've got a plus d, the third term is when we've got a plus 2d, so the nth term must be a plus n minus 1d. And that's the formula, u to the n equals a plus n minus 1d. Now you don't need to remember it because it's in your formula book. Okay, so let's see how this formula would work for us. The nth term, I've got a as 2, so I'm going to replace that with a 2. And I've got n minus 1, and my difference is 3, so that's going to be a 3. And if I times it out, I'm going to get 2 plus 3n minus 3. So I think that the nth term is 3n minus 1. Bingo, that's what I had up there. One last thing I'm going to do is introduce the last bit of notation, that the u to the n formula is known as the nth term, and it can also be referred to as L. So it can be referred to as L, meaning the last term. We're going to do 2 examples. Find the 20th term of this series. So we're going to start off by writing out our nth term formula. So any term in the series can be found by using a plus n minus 1d. Okay, so for instance, I want to find the 20th term. So the 20th term is the same as u20. Okay, easy. Now I'm going to do a lot of this. I call it overwriting. So what we do is, if we're trying to find u20, we overwrite the n. So wherever we have an n, we now have a 20. Okay, now let's go and feed in the numbers that we know. I know that a is 2, that's the first term, and the difference is 4, because it's going up by 4. So I'm going to overwrite that with a 2, and I'm going to overwrite that with a 4. And then let's see if we can work out what we've got. So u to the 20 is 2 plus 19 times 4, which is 2 plus 76, which means that u to the 20 is 78. So the 20th term in that series should be 78. Okay. Second question, find the number of terms in the series. So it's slightly worded in a different way, because this time what we're interested in doing is we're interested in finding n. We want to know how many terms there are in the series. So we're going to start off with our formula, and that's all we know so far. So u to the n equals a plus n minus 1d. And we're going to feed in what we know. So the first thing that we do know is we know that a is 10. So the first term is 10. The second thing we know, if we look at the difference, is that they're going down by minus 3 each time. So the difference is minus 3. Okay, now let's see what we've got on this right-hand side so far. 10 plus, okay, so if we times that out, in fact, we'll actually have minus, let's rub that out, we'll actually have minus 3n, and minus 3 times minus 1 is plus 3. So far we've got minus 3n plus 13. Now, there's something very, very subtle. Have a look at this. There he is. Look at him again. There he is. Can you see that that little minus 8, there he is, let's move him down, that little minus 8 is the last term. So I refer to the last term, this bit here, as the last. The letter I use for the last is L. I could also use u to the n, or I could say it's the nth. It's basically the last term. So what I'm saying here, very subtly, is that u to the n is minus 8. So a minus 8 can go into here, and then we're home and dry and we can solve it. So we're going to end up with minus 3n equals Minus 8 minus 13 is minus 21. 7, 14, 21, and therefore divide by minus 3, n is 7. So in this series we would need to have 7 terms in order to get from 10 to minus 8. Okay, here come some answers. Find the 10th term of the series. U to the n equals a plus n minus 1d. Okay, what do we know that we can fill in? So the 10th term means we're finding when n is 10, but I'm going to call it u to the 10. So wherever I have an n, I've now got a 10. The a is 3, so he's going in here. The difference is 2, that's what they're going up by. And let's work all of that out. So u to the 10 is 3 plus 9 times 2, which is 3 plus 18, which is 21. Okay, next one, find the 6th term in the series. So, write down what we know. U to the n equals a plus n minus 1d. The 6th term in the series is u6, so overwrite n as 6. The a is 10, so he can go in as a 10. And the difference this time is minus 2, because they're going down by minus 2. Okay, so u to the 6 is 10 plus 5 times minus 2. So u to the 6 is 10. Minus 2 times 5 is minus 10. So I reckon that u to the 6 is 0. Okay, number 3. Find the number of terms in the series. U to the n equals a plus n minus 1d. So what do we know? We know that a is minus 3. Okay, so he can go in as a minus 3. We also know, what's that going up by? Minus 3 plus 2 is 5. So the difference is 5. So he can go in there. And we know that the last term, u to the n, is 47. So 47 equals minus 3 plus n minus 1 times 5. So 47 equals minus 3. Let's times this out. Plus 5n minus 5. 5n minus 8 equals 47. So 5n equals 47 add 8 is 55, and therefore I reckon there are 11 terms in that series. Find the number of terms in the series 10 plus 7. Okay, so u to the n equals a plus n minus 1d. What do we know? We know that a is 10, so he can go in there. The difference, what's it going down by? It's going down by minus 3. Okay, so he can go in as a minus 3. And we know that the last term, or u to the n, is minus 17. Minus 17 is 10. Let's times this out. Minus 3n plus 3. So I reckon minus 17 is minus 3n plus 13. So minus 3n is minus 30, and therefore I reckon that n is 10.